Okay, problem number 11. You don't have this diagram here, this table. I'll hand it out either today or on Tuesday when we come back. Um, but let's read the questions, another proof. We're given a quadrilateral. These are ABCD. And it tells us its vertices. They want us to prove that quadrilateral ABCD is a parallelogram. What we can do is, here are all the ways that we can prove that a shape is a parallelogram, that a quadrilateral is a parallelogram. We have to show just one of these four things here. Okay? Show that diagonals bisect each other, right? That diagonals bisect each other. That, let's sketch out our shape, all right? So I have to show that the diagonals bisect each other. Okay? I could do that method. Or I could show that opposite sides are parallel. That's four calculations, right? One for each side. I could show that opposite sides are congruent. Once again, that's four calculations, and that's a distance one. I'm not going to do that. I'm not going to do that. But then I could show that one pair of sides are parallel. That's two calculations. And another pair of sides are congruent. Still four calculations. Way too much. I'm going to do this one. I'm going to show that my red diagonal cuts the blue diagonal in half, and my blue diagonal cuts the red diagonal in half. Because look at that. That's a point, right? That point bisects the blue one. That's called a midpoint. That point bisects the red diagonal. That's called a midpoint. The way I'm going to show that diagonals bisect each other is that diagonals share, share the same midpoint, right? If my midpoint for the red segment is the same as the midpoint for the blue segment, that's me showing that the diagonals bisect each other. And then I'm showing one of the following. So I prove that that shape must be, at a bare minimum, a parallelogram. So that's what I'm going to do. This shape is called A, B, C, D. I can trust that order. So I'm only going to calculate the midpoint, of AC, the midpoint of BD. Right? And midpoint is the average of my x's and the average of my y's. So I'm doing A and C, so I'm going to add my x's. That's minus 5 plus, where'd it go? That's minus 5, right? That's minus 5 plus 5 plus 5 over 2. That will be my x term. And then the average of my y is minus 4 and a 1. Minus 4 plus 1 over 2. Well, that will be, I'll just do it in black. Minus 5 plus 5, that's 0 over 2. Minus 4 plus 1 is minus 3 over 2. That is 0, comma, minus 1.5. All right, and then down here, we're going to find the midpoint for B and D. We're looking at B and D. The average of my x's is minus 1 plus 1. Minus 1 plus 1 over 2. The average of my y, 1 minus 4. 1 minus 4 over 2. Well, that's the same as 1 and positive 1 is 0 over 2. 1 minus 4 is a minus 3 over 2. Oh, look at that. They are the same. 0 over 2 is 0. Negative 3 over 2 is minus 1.5. They share a midpoint. All right? So those diagonals do bisect each other. Because I've satisfied one of those things when we write the proof, we're going to restate what they say when we ask us to prove. Quadrilateral ABCD is a parallelogram. Oops, too many L's. It's a parallelogram, no comma, because and we're going to state what we had to do, the one thing we had to do, because the diagonals bisect each other, and then we're going to explain why we know the diagonals bisect each other. They share the midpoint. We'll state our midpoint, 0, comma, minus 1.5. Right? That's the proof. So you can kind of close this out now if you like. I'm just going to quickly talk about the proof and why it makes sense. Quadrilateral ABCD, the thing they gave us, is a parallelogram, the thing they're asking us to prove. Because the diagonals bisect each other. The one thing I had to show to prove that the thing they gave me is a parallelogram. How did I know the diagonals bisect each other? Well, because they share a midpoint. And that's the one I found for both of them. Quod erat demonstratum, thus proving what we set out to demonstrate.